the previous lecture I was talking about the glass, and I think I was talking about socio-economic technical issues related with the glass. Glass has become a very interesting industrial domestic byproduct in today's world. Particularly, I have been professing the application of glass for artificial beach creation. There is something known as beach nutrition. So, sea beaches can be created overnight. What you have to do? You have to take the unused glass, crush it, and that is similar to the sands, and this sand can be utilized for making beaches and different other artificially created systems. You will be surprised to know that a lot of applications are already there in the industry. So, the crushed glass would look like this. It is similar to the sands. It is being used in construction aggregates as a fill material, filter media, glass fault, tarmac. A lot of people are making value added products out of it, fused glass, art glass, terrazzo composites, foam blocks. You must have come across hydroponics, is it not? Hydroponics are nothing but they grow plants without soil. So, this is something very interesting, people have been doing this, and they can also be used as an abrasive in the mineral sector and as a filler material. So, depending upon this, there are a lot of applications. This can be used in concrete also, because composition wise this material is going to be same as quartz. So, in road base filled trenches, this can be a good filter media for wastewater treatment. You can replace sands, and sands are not available right now. As I was discussing, specialty users like beach sand, sand nourishment of the beaches. If you want to create a different type of landscape, then there you can use this, and glass fault is a new term. Then comes the dredging. This is something which is magnanimous. Long back I had told you in the class that nowadays geographical boundaries of the country keep on changing, particularly in the coastal areas. So, in coastal areas, if you see through the net and the web, you will find a lot of case studies are available where the artificial land was created by dredging. So, there are different types of dredgers which are available in the market. So, these are suction dredgers. So, what you are observing here is there are a lot of pumps on the ship, and they suck sands, and then this is what is known as the rainbow methodology for sprinkling sand on the seashores. So, the whole area has been developed like this, and the sand gets deposited because of the natural phenomena. Sediments, they get deposited in the bays or the ocean bodies, ocean surface, and then you can create land out of it. Do a bit of internet checking and you will find that most of the airports which are coming up recently internationally, they are all sitting on the dredge sediments. Japan is a beautiful example. Osaka airport, you can see that these are satellite airports, they are not part of the land, they do not have land. So, what they have done is they have created a satellite airport in the sea, and they have connected it with the viaduct to the mainland. There are some beautiful examples of advanced geotechnical engineering which is being done. Yeah, different type of islands, Palm Island, Pearl Islands. In our own country, a lot of activities are being done in the Indian Ocean. If you check on the net, both for strategic as well as for civilian application. And Chinese example you must be reading in everyday newspaper. So, they have created thousands of islands, and what they are doing now in the South China Sea, they are not allowing traffic, they charge toll, and then these lands are now becoming strategic lands where they can do strategic activities. So, it is an expansion of the country. Imagine, we never bothered about these things, but see, these are the activities which geotechnical engineers are involved with. A lot of interesting videos are there where many projects are going on in Bombay City, where they do deep ocean blasting. They cut the rock, they blast it, they take out the rocks, they bring it close to the sea shores, and they create seabeds, sea beaches for strategic activities and for public activities also. Alright. Now, what are the beneficial applications of the dredge materials? There are several applications of the dredge materials. So, I have included few industrial byproducts, because dredging is an industry, and dredging is normally done for two purposes. One is for maintenance, if lot of siltation occurs in the channels which are bringing ships to the what do you call it, to the, let us say, port, seaport. So, ships which have big hulls cannot really navigate through. So, you have to first maintain the channels, the way you maintain channels in your drains in your household. Second is what is known as when you are creating infrastructure. So, one is the maintenance dredging, another one is capital dredging. So, capital dredging is normally done to create infrastructure in the ocean, in the oceans or the lakes or a water body. So, these are capital dredgings, but there are a lot of challenges. So, I had been doing projects from different ports, and I have been guiding them how to utilize these materials for beach nourishment, shore protection, soil creation and enhancement, land reclamation, different type of habitat restoration. So, these things are becoming a part of geotechnical engineering. I do not think that someone else is going to do all these things. Only you have to be an expert tomorrow to guide the industry or the ports in the country. Habitat restoration would be a very good example of the guys who are more interested into conservation of wildlife, aquatic life. So, if you are creating a facility or infrastructure somewhere in the water body, the aquatic life gets disturbed, is it not? You have disturbed the marine environment. So, now people have started pitching in this concept of how to restore this habitat. So, they create islands for flora and fauna to flourish, and these are dedicated places, and I am sure that you can realize that geotechnical engineers play a very important role in this area. Soft clay engineering, because most of these deposits, after taking out from the sea, you are going to place on the seabed itself. So, consolidation, settlement, all these things you have to study, strength, shear strength parameters, and how would you create an embankment which is 2/3 submerged in water, 1/3 coming out of the water, and so on. Now, when it comes to the characterization of the waste, this is a very big subject. So, as I said in the beginning of lecture today, that before you start using the material for a given application, for a given project, first thing is you have to understand what are the fundamental properties of the material, and this is where you have to characterize the material. There is a big series of tests which has to be done. Water content, because most of the time these materials are having enough water in them. Density, granulometry, what is their flowability. So, when we talk about the granulometry, you should check his papers by Rakshit Shetty and myself. We have done, I think we have published 3-4 papers on use of dredge sediments and then the geological characteristics of sediments. And you have to test these sediments for following constituents: organic content, carbonate content, different type of heavy metals which are present in the system, organochlorines which are present in the system. Most of the time these heavy metals come in the sediments because of the discharges from vessels, ships. These soils could be hydrocarbon contaminated also. So, it is a big issue. Most of the industries in the coastal regions, they cannot withdraw water because of sedimentation for running their plants, cooling towers and boiler units and so on. PAH, then toxicity test has to be done, because if you are utilizing a material which is a dredge material, and the question would be where to dump it, and after dumping it should not become toxic to the environment. You have to do a lot of clinical examination of sediments. Not many laboratories in the country and the world are full-fledged, material characterization laboratories. So, this is where interdisciplinary approach has to be adopted and a lot of work has to be done. So, here I have listed thermal and chemical stability also. You are talking about this thing. So, when you are creating islands by reclamation, the first question would be you are using what type of material, sediments from the sea or the water body, and whether they are organic in nature or not. Organic systems cannot be utilized because they will keep on consolidating and they will decay. But imagine when you create big lands, how would you test each sample? It is not possible. It is a big challenge. Similarly, thermal stability, because once you take it out and expose it to the environment, UV and sunlight, the chances are the sediments may decay. I mean, this is one set of the experiments which has to be done, where I have not talked about the geotechnics related aspects. It is just the material suitability first of all, and once you say that the material is suitable, then you test it for its mechanical and engineering and geotechnical engineering characteristics. So, that becomes a big series. So, this basically shows that why characterization of waste is becoming important industrial byproducts. And from this point onwards, I shaped up my research in what I call as physico, chemico, mineralogical, thermal and electrical characterization. So, these things we have already mastered, we are quite comfortable. Physics of the material, chemistry of the material, mineralogy of the material, thermal characteristics of the material, electrical characteristics of the material. Now, the bio components and all slowly and slowly I am adding to, but it seems to be a Herculean task. So, people like you should come forward and take it up and plug them in this matrix of knowledge to make the holistic picture. Otherwise, it is not going to be easy. So, Shashank's thesis was one good example of what happens when bacteria interacts with the geomaterials. So, that was a very fundamental work which we did. You must have realized we were trying to create a lot of questions in mind first of all, and then we were trying to answer few questions which we could. So, once you characterize the waste, you can understand how this material is going to behave and how to recommend proper utilization schemes. As I said some time back, there are guys who are talking about the waste mechanics. It is a new concept which is becoming a part of environmental geomechanics, where not only the municipal solid waste, but industrial byproducts and particular dredge sediments are being tested, and the whole mechanics is being created out of it. Maybe 1930s and 40s, when soils were tested and soil mechanics came in force, no wonder under 2-3 years you will find that waste mechanics will become a big subject. So, this is how the knowledge keeps on spreading and bifurcating and new subjects get created.